All right, so welcome everybody. Welcome to Landscape Pesticide Calculation. We're gonna look at a few slides, and as soon as we finish that up, we'll kind of work out some pesticide problems. So we'll talk for probably 20 minutes, and then the last 30, we'll go over roughly 12 problems. A couple of the problems have multiple sections, but very easy. So if you've got some scratch paper and a pencil, an eraser, and the readers, if you're like me, I'm getting old. I can't see a thing. And that's probably, Kenny, why I haven't read your emails, because I always forget a pair of reading glasses. And I can't read a thing on my phone without them. But anyway, this course is good for one pesticide credit, L, D, and X. I'll have to go back and look at maybe for a lot more too. Usually I have to go back to the Department of Agriculture's website and it'll tell me everything. But I always request a lot more than they give me credit for, but I know every single one that I do is L, D, and X, so ornamentals and turf, because we're talking about turfgrass calculations here. So our objectives of the course, landscape contractors or pesticide applicators. We're going to work on some common pesticide calculation or pesticide application calculations. We will calculate basic pesticide application math problems. We will present calculations to each other and myself. Then we'll review the calculations with the instructors. Basically, we're just going to go over this stuff together. And then they'll be able to include pesticide services in your landscape management plan. If you are doing it. How many of you guys are actually applying pesticides every single day, either in a fertility program or your landscape management services where, basically just playing for, weeds and shrub beds and stuff? Is everybody actively doing it?
No.
Anybody else? Everybody else?
Yes.
You're doing it, Jill? Got you. And it is a very lucrative, very profitable business. The one thing that it does require is the individual who's probably a little more knowledgeable in the green industry than, say, our mowing crew leaders or mowing crew members. It's going to take that individual who doesn't mind working by themselves and can actually do some of these calculations on their own. And because when it comes to calibrating our equipment, when should we calibrate our equipment? What does our core manual say? What does the North Carolina Department of Ag core manual say? How many times a day and when should we calibrate our equipment?
Every day when you got to use it.
Do what?
Every day when you're going to use it.
Every day. And it's the technician who's going to use it. Now, is there multiple times during the day that individual may need to calibrate?
Yeah.
Yep. For one, if they're changing pesticides, here we're in Winston-Salem, North Carolina, so we've got neighborhoods that are completely flat, and then we've got neighborhoods that's got some rolling terrain in it. So definitely we would want to calibrate if we're moving from neighborhood to neighborhood. That's why you got to kind of schedule everything based on your terrain. But what about some other times? Necessarily, does the core manual not talk about this, but about some summertime applications when we may want to recalibrate. And I know a lot of people don't want to do calibration, especially multiple times a day. But with the cost of these pesticides and these products that we're putting out, we can save ourselves a lot of money. And it just takes a little bit of time to actually calibrate the equipment. But when else will we might want to do that? What about on those hot summer days when, we start out pretty early in the green industry? We're out there early mornings, we're making our applications, but we've gotten behind, and so we're having to hustle a little bit and work a little bit later. When might we recalibrate? As the day progresses, what happens? It gets hotter. We get tireder. if we go and we get a 12-inch sub at Subway instead of a salad, we're filling up and we're getting sluggish and we're getting heavy. And so what happens to us as we get tired, as we eat a lunch? We're going to start walking slower. So if we're walking slower, what's happening to our application rate?
It's getting heavier.
It's getting heavier. We're putting out more than we possibly need. So I would really love to sit down and work some of those problems out, or figure out a math way that we could say, hey, yeah, we're going to save X amount of dollars if we did recalibrate at launch, because our guys are going to they are going to slow down. And towards the end of the day, they're trying to hustle and bustle so they can hurry up and get home or watch the football game or something like that. They're going to pick up speed. And so then their application rate is going to drop a lot lower. So basically, basic geometry, 10th grade, we never thought this would ever help us in real life until we get into landscaping, landscape construction, and definitely lawn care. But flat yard, square yard times width, triangular. We have base times the height divided by 2. And then for our circular area, we have a math problem that we are going to look at with a circular area of turf grass, but it is pi times r squared. And as you can see there, we have a radius of 90 feet or a diameter of 90 feet. So we know our radius is going to be 45. We square that times pi, which is a constant of 3.14, and we can figure out our whole surface area of a round patchular or round area of turf grass. And some more, easy problems here that we would see. And basically here it's just an example. You have determined from a calibration test that your boom sprayer, and I love boom sprayers on the back of lawn tractors or your perma greens or your steel greens. All of those machines are super nice, and you can get a lot of work done pretty quick. But we've determined from our test that our boom sprayer delivers 10 gallons of water over 1/4 acre test area. You need to apply a pesticide product to a 10-acre field. We know that there's 43,560 square feet in the acre. And then the pesticide label recommends that 4 ounces of liquid product be added to give a desired finished spray mixture of 1 gallon. There's 128 fluid ounces in a gallon. How much spray volume and how much product is needed. Now, so there's 2 questions right there. What is our spray volume and how much product is needed? And always, when I first got into this business, all right, they're like mix 3 ounces per gallon, and you have a 500-gallon tank. You're going to put 500 gallons of water. That's what it to me it seemed like, and then we would dump our pesticide in it. But if I do that, my solution is going to be diluted. You have to subtract out from your water the amount of ounces of product that you're going to put into it, and then mix it all together. And so, step 1, how much spray mixture is needed for the 10-acre application area? Always use the information from your calibration test. We would do that prior to doing it. So in this example, 10 gallons of water was used over a 1/4 acre calibration test area. So we have 10 gallons over 1/4 of an acre. We're doing Y gallons over 10 acres, and we're going to cross, multiply. So Y is equivalent to 10 gallons times 10 acres divided by a 1/4 acre. So we need 400 gallons of spray mixture. Step 2, how much pesticide product is needed to make up 400 gallons of spray mixture? Use the label rate of 4 ounces of product per 1 gallon. Now, we have to use our labels. We have to read our labels. And we need to read them all the time. You're not going to remember this stuff. I don't remember it all. So you got to read it, print them off the internet, put them in a 3-ring binder. They're going to get destroyed on the 2.5-gallon jug. You get copies from your dealer when you go to the Green and Grow show. I love getting all these, product labels from them and our MSDS sheets, and just boom, right into a 3-ring binder. And so 400 gallons of spray mixture times 4 ounces of liquid pesticide product per gallon equals 1,600 ounces of product. How many gallons of product are needed? Remember, there's 128 ounces in a gallon. So 1,600 divided by 128, we need 12.5 gallons of product. So for our 10-acre site, we need a total final spray mixture of 400 gallons that includes 12.5 gallons of the concentrated product. So we're only going to put 387.5 gallons of water into our tank, and then we put the 12.5 gallons of our product to make up the 400 gallons. And so with calibration, again, check for misapplication. Keep an eye on the amount that you're actually applying for the load you calculated. And if something is off, stop and check your calculation in your equipment. You can catch and correct any errors before it is too late. So again, calibration is key for your technicians out there. And so now we're going to actually look at some, barricade problems. And I know the price of this stuff is going up. When we put this slide together, this is years ago, but the math has not changed. You would just actually substitute in what your cost is for the product. And so we actually have one here. How much would an application of Barricade 65 water dispersible granulars cost for an 8,000 square foot home loan if the labeled rate is 1 pound active ingredient Barricade per acre, and Barricade 65 WDG is $39.95 per pound? And then how much would an application of granular combination product cost for the same lawn at the same rate? And so when we are using dry formulations, the number on the label refers to the percent active ingredient by weight. Example, this Barricade 65 water dispersible granular is 65% by weight prodiamine, and therefore 100 pounds of it contains 65 pounds prodiamine, and one Barricade 65 WDG contains 0.65 pounds of prodiamine. When we're using our liquid formulation, the number on the label refers to the pounds active ingredient per gallon of product. So Barricade 4FL has 4 pounds prodiamine active ingredient per 1 gallon of product. And so if we purchased a 2.5 gallon jug of Barricade 4FL, we have 10 pounds of prodiamine. 4 pounds active ingredient over 1 gallon times 2.5 is our 10 pounds active ingredient. And so how do we get to how much it's going to cost us? We're going to use it through dimensional analysis. Learned this at a pesticide seminar that I went to years ago down at NC State, like a field day turfgrass, and it was cool putting all these problems together. And so dimensional analysis, you're starting with what you have to get to what you want. So what is it that we have? We know that we have an 8,000 square foot home loan, and we're trying to get to what our product costs. So basically in this, all we're worried about is how much we're spending on the chemical. Everybody's overhead, everybody's pay rates and things like that are different, but we can exactly get to the exact same cost on what we're spending on products. And so let's look at another example that might be a little bit easier. And we have truckloads. We have truckloads of beer that's going to be delivered to a convenience store. And there are 1,000 20-ounce drinks per truck, and they cost a nickel per ounce. And so we're going to figure out how much we're spending on beer being delivered to these convenience stores, grocery stores, or whatever. So we're starting, remember, with what we have truckloads. We want to get to our cost. And so put our little pin here. We have our truckloads. We have our cost is where we want to end up with. So beginning with the unit that you have, proceed to the unit that you want by canceling out these units through multiplication. So we've set these little charts off, and this is the easiest thing to do when we're doing our pesticide calculations. And we may not need all these columns. It just depends on what it is that we're trying to figure out. So we have 5 truckloads. There's 1,000 beers per truckload. There's 20 ounces per beer. And then each ounce costs us a nickel. Well, if we jump to the next slide, we can see which one are canceling out. We have our truckloads. They cancel out. The drinks cancel out. The ounces cancel out. And we are left with that dollar sign. And that's what we're trying to get. So we say 5 times 1,000 times 20 times a nickel is $5,000. So that's what we're spending on our beer being delivered to the convenience store. So how much would the application of Barricade 65 WDG cost for an 8,000 square foot home loan if the labeled rate is 1 pound active ingredient per acre and Barricade 65 WDG is $39.95? Again, we're starting with what we have to get to what we want. We have the 8,000 square foot home loan. And that was the typical lawn size back in Raleigh back in the day when we did this presentation. So we're basically setting up here. We have the 8,000. It really goes right here. I just wrote it a little bigger. So 8,000 is right here. There is 1 acre with 43,560 square feet. We have 1 pound active ingredient per acre. We know that 1 pound of Barricade is 0.65 pounds active ingredient, and that we know that 1 pound of Barricade costs us $39.95. And like I said, that price has changed. And so when we start going over this, we know that the square foot cancel out, the 1 acre cancels out, the pound per active ingredient cancels out, 1 pound of Barricade cancels out, and we are left with that dollar sign. So we multiply 8,000 times 1 times 1 times 1 times $39.95. We have 319,600. We have on the bottom 43,560 times 1 times 0.65 times 1 is 28,314. Divide that into your 319,600, and we are spending $11.28 for that 8,000 square foot home loan. That's what our product cost is. And so what can we do with this information? If we were to do this, December, late November, or even early January, and we know how many square feet of turf that we are managing. And we should know that. We should be able to quote that really quick. How many square feet of turf grass are you guys managing if you are in the lawn care industry? Some companies, it's up in the millions. It just happens. You can get several, lawns if that's what you're focusing on, and build several lawns up. And if you know how much total square feet, I would like to actually take that number to 1,000. And I like the 1,000 because everything on the product label is based on 1,000 square feet. So if we know that $11.28 for 8,000 square foot, how much are we going to spend for that 1,000 square foot section? And if we had millions of acres of turf, we could figure out exactly what our product cost will be for the year, for each application, for each round, and total for the year. And that's nice. The one thing I've always thought about lawn care, it is a very good business model because your numbers are there. And you can figure out how much you're going to spend. Then you can figure out your overhead. You can figure out your profits very easily. I think it's a lot easier to do than actual mowing, because really, to put out this product, what all do you need? You need a fertilizer spreader and your backpack sprayer, and you are 100% in business. Now, are you going to get a lot done? No. But then you move up to your ride-on spreader sprayers, and you can cover some ground really, really quick with those. But still, I love getting out the backpack sprayer. I love pushing a fertilizer sprayer. It's something I like doing, and it gets me connected with our client's property because it's called boots on ground. You're walking the property and you're seeing it. If you're riding a piece of equipment, you may be going a little fast. You're not able to pay attention to what else is going on with the property. And so that kind of concludes our examples that we're looking at and going over. And we're right. I was right on the money. So we got 30 minutes, to do a 50-minute class to give you 1 hour credit. we're actually going to work some problems here on the PowerPoint. So if you've got some scratch paper and you've got some a pencil close by, go ahead and grab that, and we'll jump into the very first problem. So question 1, a product label prescribes 2 pounds per acre. How much is needed for a 4,800 square foot lawn? Remember that 1 acre, again, is 43,560. And the easiest way, you're going to really just divide it. You're going to divide your 4,800. This takes me a little while. I'm drawing it with the mouse. And then we have our 43,000. This is basically all we have to do for this. But they're both square feet, and that's going to give us what? 0.1 acre. So very tenth of an acre. And so for our product, if we have 2 pounds per acre, we're going to multiply the 0.1 times 2 pounds. Gives us 0.2 pounds. And if we wanted to get that to ounces, how much is it? Then we just multiply that times 16. So 16 ounces in a pound. We need 3.2 ounces. So easy enough with that one. And we could have set it up dimensional analysis, but that one was just a little bit easier to do that way. So question number 2. The product label says that we need to use 3 ounces per 1,000 square feet. How much product will you need for a 4,800 square foot lawn? So again, I'm going to set it up that way. We're doing 3 ounces, 1,000. And we have what? 4,800 square feet. It may have been easier just to divide that. What does that give us? Y'all help us out.
We're dividing that by 4,800.
Mm-hmm. So if we divided, actually, you know, those cancel out, but
Right.
we'd get 4.8 times our 3 ounces.
14.4.
Is a 14.4. We need 14.4 ounces of our product. And are we doing this every single time we show up to a property? Or are we guesstimating?
Guarantee there's some guesstimation going on.
There is, ain't it? You know, our employees aren't doing this. Like I said, that is you know, they're not doing what they need to be doing. Kind of like running Walker mowers. They are a owner-operator machine. I don't like the guys taking those out. They're going to destroy it. Okay. So question number 3. You need to spread a crabgrass herbicide over 2,400 square feet area, and you purchase a 25-pound bag for herbicide. You know, very seldom do we do that. But the label states that the contents of the bag will cover 5,000 square feet. How much of the bag will be needed? So we have our 2,400 square foot, basically. divided by 5,000. They're both square feet.
.48.
That is per bag. And basically we get 0.48. We're going to multiply that times our 25 pound bag.
12
We're going to have
pounds.
12 pounds.
Yep.
Easy enough. Question 4, you need to apply grub control insecticide over 4,800 square feet. The label instructions say to apply 1 gallon of water and 4 teaspoons of insecticide for each 200 square feet. How much water and how much insecticide is needed? So we got 2 actual sections here. We're going to figure out how much water we need, and then we're going to figure out how much of product we're going to need. So for our water, we got 4,800 divided by 200
24.
gives us 24. We need 24 gallons. So for our product, the insecticide,
We have a teaspoon.
we have 24 gallons that we're using the math. And we need 4 teaspoons for each 200 square feet. On 4. It's a 4 right there. Gives us 96 teaspoons.
Yep.
I don't like it when we're dealing with such a small product per 24 gallons. So how many cups do we get? I'd really use volumes like that. How many teaspoons in a cup? 48, right?
48?
48 teaspoons is a cup. So 48 will go into 96 too, so it'll give us 2 cups.
Yep.
But I bet my employees could figure that out with little teaspoon stuff. They're not used to dipping out pesticides with that, though, are they?
Nope.
Y'all don't find that funny, do you? Y'all don't have a problem with employees doing bad things?
Wasting
Oh,
product.
cool. Do what?
So it ain't nothing like wasting good product.
Yeah,
It's just money.
just money, ain't it? Just money. Question 5. You want to make 3 gallons of a 6% solution of a broadleaf herbicide. How many ounces of herbicide are needed? Round to the nearest ounce. So with that, we're just going to we got to convert it to decimal form. So 6 divided by 100 equals 0.06. And we're going to multiply that by 128 ounces in a gallon. Gives me 7.68. Then we multiply it by 2.
15.36.
I actually multiply it by 3. Sorry. What does that give us? I can't do that math in my head. Not after a day like today.
It's 23.04.
23.04. All right, question 6. Determine the amount of granular insecticide needed to treat 4 acres, assuming a label rate of 4 pounds per 1,000 square feet, round to the nearest pound. So we're going to take 4 43,560.
$174,240.
Yep. Good job. So we got our total square foot there. Then we're putting out 4 pounds per 1,000.
Times 696. 960.
I guess it depends on how many times we carry out our decimals, or, we're right there at 697.
Yeah.
How many 50-pound bags?
697.
Quite a bit. About 50.
Yeah.
Well, insecticides may come in 40 pounds. Just depends on what we're getting. There's question 6.
I would say, well, if you're rounding.
Do what, Kenny?
I'm just talking to myself.
Oh, I do that all day, man.
Hey, I tell everybody I do that when when you need good advice, you need to talk to yourself.
Talk to yourself. I talk to myself because nobody else wants to talk to me. I used to be the biggest extrovert. I think I still am, but I am becoming more and more where I'm okay just to do something by myself. Question 7. How much spray solution will be needed to treat a 9,000 square foot lawn if your sprayer is calibrated to deliver 6 gallons per 1,000 square feet, round to the nearest gallon? So, again, 9,000 divided. I always take that and I figure out how many 1,000 square foot blocks do I have on a property. So we got 9,000 square feet, divided by 1,000. It's going to give me 9. And then we're putting out, 6 gallons per 1,000? We're going to be
54.
54. Easy enough. Guys, we're getting through this too fast. We're going to have to slow down. Y'all don't want to be on here a full hour, do you?
We don't and say we did.
Kenny and James only one talking. Jill got Brad turned off on the camera. He can't even figure it out. Or is he sitting beside you, Miss Huff? Question 8. A 4% solution of pesticide will contain how many fluid ounces of pesticide per gallon of mixture? So we got a 4% solution. Again, convert it to decimal form. 4 divided by 100 is 0.04. And then we're going to multiply that times 128 ounces that is in a gallon. That's going to give us 5.12. Easy enough. Now, here is the typical lawn care program. It's got 2 parts, A and B. You're spraying a pesticide to a lawn. The total lot size is 1/3 of an acre with a 25 by 43 house footprint. And we have a driveway that's 15 feet wide, 40 feet long. How many square feet will you need to spray? And so basically what we're doing is figuring out how much square footage that this property has. We got to minus out the house, and we got to minus out the driveway and any other sidewalks, shrub beds, or anything like that on there, because you're not going to be putting product there if you're just taking care of turf grass. So we have 1/3 of an acre. So 1/3 times our 43,560 gives us 14,520 square feet of the total property. We have a house that is 25 by 43. Gives us 1,075 house footprint square footage. Then we have our driveway, which is 15 by 40. We have a 600 square feet. Add those two together, and that gives us, we could add them together and then minus everything right over here.
So 12,847. I think
14,520 minus 10 minus the 17, 1,673 minus that.
Oh, yeah.
So what are y'all getting? Yeah, 12.
12,047.
12,847.
So what y'all got? 12,845. So that is our square footage of turf grass that we are actually going to treat. So part B, the label says to apply the pesticide at the rate of 5 fluid ounces per thousand. How many ounces of the formulation will you need for this area? And again, we're just asking for what our formulation is. And so we have 12,845. Again, we're going to figure out how many 1,000 foot or 1,000 square foot blocks we have. We're going to have 12.845. We're going to multiply that. And really, you could probably just do that 0.85 rounded up, 12.85 times 5 ounces. Then we're going to equal 64.25 ounces. Is what we need for that job. All right, now we have a wettable powder. You are working at a 35-acre horse farm with 30 acres of fenced-in pasture. You need to apply 5 pounds of active ingredient of herbicide per acre to the pasture land. The herbicide is a 60% wettable powder. And how many pounds of formulation must you apply to the acre? So very, very easy to do that. It's 60% wettable powder. So we got 60 over 100. So we're getting that, decimal form equals
0.6.
5 pounds X. We do a cross multiplication. 60X equals 500. Get 8.33 pounds. Now, I didn't really need to know the 30 acres, right? Because it's asking us just how many pounds of formulation must you apply per acre. And now, we do have a 35-acre horse farm, 30 in that, but the question only asks us per acre. So we need 8.33 pounds per acre. If we wanted to figure out an amount, the 8.33 times the 30 for the actual horse pasture. Question 11, your boom sprayer holds 20 gallons of herbicide. It has been calibrated to apply 0.5 gallons per 1,000 square feet. Will you be able to spray a 1.5 acre site without refilling? So it's a yes or no question, but you still got to do the math to figure it out. We have 20 gallons of herbicide, or 20 gallons. The boom sprayer will hold that. So we're going to know 20 gallons. We know what we have. It's going to do 0.5 per 1,000. And we know what 1 acre is, 42,560. So if we do our acres, how many 1,000 square foot blocks do we have? We're going to have 43.56. If we divide 43,560 by 2, because we're doing 1.5 acres, it's going to give us 21,780. Divide that by 1,000 for our blocks. We're going to have 2178.
Yeah.
Add those together is going to give us 65.34 times our 0.5 ounces. That gives us 32.72 gallons. So we're gonna have to make 2 trips. We're gonna have to do 2 tank pulls. So we're gonna do one with 20, and then we'll have 12.72 to finish out the job. So no, you can't do it without refilling. And our last one, and we have a few minutes left. You're applying a fungicide to a circular patch of turf with a radius of 75 for a public garden. The application rate on the fungicide is 4 ounces per 1,000. How many ounces of fungicide will be needed to treat the turf? And so we know that we're doing 4 ounces per 1,000. Going ahead and writing that down. The area of the circle is pi r squared. So we know that pi is 3.14. And we know the radius. So it's already given us the radius. So 75 squared. And that's going to be 5,625 times the 3.14 gives us 17,662.5 square feet. Divide that by 1,000. How many blocks do we need? It's going to give us 17.66. We're going to multiply that times our 4 ounces.
Or 70.65.
Yep. 70.65 ounces of product or fungicide needed for that job. And so we have about 6 minutes left. Are there any questions, comments, concerns about any of these problems? Do we need to go over any of it? We need to talk anything else about plugging, seeding, fertilizing, getting ready for that last round of the year, which I think probably the most important. Clients that do pay for that, 5th or 6th app in December will have a good start for the summer. You can tell a difference if they don't get that late winter food, that they're going to have a little slower start in the summer. And believe it or not, people are still calling for plugging and seeding, and it's getting a little late. But here it's the 24th of October, and people are still wanting that done. And I don't know why they call late, and trying to get it done. I'd almost rather wait till spring, but we still got a few more to do. All right, so let me go ahead and I'm going to stop the share. That way we can all see each other. So, any questions, comments, concerns? Or is it dinner time? Or is it time to chill?
Time to go make some dinner.
I'm sorry, Kenny.
I said time to go make some dinner.
That's right. I haven't ate either. I don't eat till 8, 9 o'clock every night.
That's my problem. Then I take a shower and crash.
Yeah.
Yep.
Yep.
And then get up at 4:30 and do it again.
That's right, dude. And I don't even have to set an alarm. Like
No,
4:30 is
yeah.
automatic.
I was wide awake this morning at 3:00 and I just got up.
But you'd have felt worse. You'd have felt worse if you'd have dozed back off.
If I'd have dozed back off, I wouldn't have got up at 4:30.
Yeah. Yep. So
That's
that's the green industry, ain't it, man?
yes, sir.
Anybody go up to Expo last week? Anybody else go? The best trade show in the green industry. $25 gets you in. Like, it is very inexpensive. With every piece of equipment, every turf grass piece of equipment, tractor, everything's there, and you get to demo it outside. So fun time. You wore out. It's actually harder than work because you're trying to do everything that you want to do. You want to try everything that you can. So it was very fun. Very fun. First time with my dad not being there with me, so it was kind of tough. But good friends that are always there. Well, guys, we got about 4 minutes, 3.5 minutes. So we'll go ahead and end this. I will go ahead and upload the roster, and you'll see it immediately. And then, Kenny, I'll check that email and get you those receipts.
Yeah, I appreciate that. Thanks a lot, Eric.
Thanks, guys. Y'all have a good evening.
Thanks, Eric.
You too.
See you in the next class.
Bye.
All right. Have a good night.
You too.